Hi everyone, so in this video we'll talk about another container in STL that is called multiset. Okay, so a multiset is a variation of set, and as the name suggests, it's a set like container that can store multiple elements that have same values. Okay, so we'll see how we can use this container and how we can solve some problems using this container as well. All right. So the very special thing about this is all elements are stored in a specific order. Okay. So there is some ordering, and that order is sorted according to the internal comparison object. Okay. According to the internal comparison object. So you can probably give your own comparison object to do the sorting like we have done in other cases as well. But if it is a integer or a string, so then by the default comparison integers are sorted in the ascending order. That's how they are going to be stored. Okay, and another thing to note is once the values are inserted in the set, they cannot be modified. So you have to make those values as constant. So values once inserted cannot be modified. So you have to remove that value and insert a new value if you want to modify that particular value. And it is a associative container. That means if you want to refer an element, you have to refer it by key. So keys and values are same in this case. Okay, so you can call it as a key or you can call it as a value. So both are going to be same like a set, and elements are referred by their value and not by the index. Okay, and one final point about this is the underlying implementation uses a binary search tree to implement a multi-set. Okay, so underlying implementation is a BST. Okay, so that's what you need to know about this container. Now let us see few examples and how to work with the multiset. Okay, so first thing is you need to include the header file called set. So let's include the header file set, and set header file contains both your set and multiset as well. Okay, so let's create an array and we will try to uh, create a multiset from the array. Okay, so let's say we have 10, 20, 30, 20, 10, 10 in the array. So now you can see multiple elements have the same value, and I am going to create a multiset out of it. Okay, so let's say multiset of integers. Let's call this as m, and I give the elements of the array. So I have 6 elements, so I give array plus 6. And now let's try to iterate over the multiset. Okay, so you can use iterators. You can also use a for each loop like this. You can say for every element x that is there in the multiset m, you can do a cout x. So let me try to run this code. You can see these are the elements, and now you can see these elements are stored in the sorted order. But if you had used a set, then the elements with the same value are inserted only once. Okay, so that's the difference between set and a multiset. So let's keep working with the multiset, and let's see a few more operations that we can do. Now suppose if you want to erase a particular element. Okay, I say I want to erase 20 from this particular set, and 20 is occurring 2 times, so all occurrences of the 20 will be erased. Okay, so let's try to run the code, and you can see all occurrences of 20 are erased from the set. We can also insert elements using the insert function. So if I say okay, I want to insert a number called 8 in the set. Okay, so let's insert 8 in the set. So I can say m dot insert 80. So that's pretty simple. You just call the insert function and give it the data you want to insert in the multiset. And now you can see it has 80 in the set. Also, you can check how many times an element is occurring using the count function. So you can say int count equal to, or you can say m dot count of let's say 10. Okay, and I just print this count, so cout m dot count, and this should give the count of this is 3 actually. Okay, so maybe write the count as, okay. So another function you can have is a find function if you want to get an iterator to a particular element. Okay, for example, if you want to get an iterator to 30, let me insert one more 30. In this case I'm replacing 110 by 130. So let's say I want to get an iterator to the element 30. I can say auto it equal to m dot find 30. So this will give me the first element that is equal to 30, and if I do star of it, so that will give me 30. You can see. Okay, so maybe put a handle here. So we are actually getting this as a 30. So but suppose you want to get two iterators, and maybe you want to get all elements which are equal to 30. Okay, maybe something like this you want to do. So maybe let's add few more 30s, and here now I do int n equal to size of arr upon size of int and arr plus n. So there is a function called equal range that will give us a pair of iterators. So m dot equal range, let's say 30, and this will help us to iterate over all elements which are equal to 30. So I need to create a pair of iterators. So the data type of the iterator would be of this type: multiset of integers colon iterator. Okay, and I need to give this data type 2 times. So or I can do is I can use type def this thing as it. So I define a new data type it that is actually this data type using type def, and I can create a pair of this. Okay, so I can say pair of it comma it, and let's call it as p, and this is equal to m dot equal range. Okay, so let's iterate over this range. It equals to range dot first, it not equals to range dot second. Okay, so this iterator is the iterator pointing to the first 30, and this iterator is the iterator pointing to the last one step ahead than the last 30. Okay, so that's range dot second it plus plus, and here I can do cout star of it. Sorry, this is, let's call this as range. Okay, so I call that pair as range, and I'm iterating over range from right, so I should have a semicolon here. Okay, so I created a pair, and the pair now contains two iterators, one to the starting 30 and one to the ending 30. So you can see we are able to iterate over a range of numbers that are equal to 30. And let's discuss one last function, that is lower bound and upper bound. Okay, so suppose you want to iterate between a range of numbers, maybe between 10 to 100. Okay, so for that you can use a lower bound function, it equals to m dot lower bound. So you will start from all numbers which are greater than equal to 10, and you will stop before all numbers. So upper bound means greater than something. Okay, so let's say you will go till all numbers. So upper bound of 77 would give me the first number that is greater than 77. Okay, so let's say that number is 80. So we will stop before 80, so we should get all numbers from 10 to 30. I do it plus plus, and if I do C out star of it, we can see. Okay, so let me put a hyphen here, and that's it. Okay. mm, so we have one error. Okay, let me try to debug this one. Sorry, this should not be end, this should be auto. Okay, so this is the mistake. Okay, so a small mistake here. So the data type is multiset, and so we have yeah, this should be a semicolon. Okay, so I think now it should work fine. We should get all the numbers in the range 10, and which are greater than equal to 10, and which are not greater than 80. Okay, or not greater than equal to 80. So this will be 80, this will be iterated to 80, and if I do 80 here, I will get something as map.end, and this will actually print 80 as well. Okay, you can try. So you can see this is the output, and if I put 80 here, so that will also include 80, because this iterator will give me map.end, because there is no such number that is greater than 80 in our multiset. Okay, so I hope you got an idea how to work with multiset, and that's all for this video.